Hello and welcome to the Comparesoft CMMS Podcast. In this episode, we're looking at maintenance in FMCG manufacturing. I'm joined by Ibnu Pookkayil, Engineering Supervisor at Gosh Food, a UK food manufacturer based in Milton Keynes. Ibnu started his career in food production in Saudi Arabia before moving to the UK in 2019, running maintenance across 4 production lines with a team of 5 engineers. We'll explore what it takes to run maintenance at a small to mid-sized FMCG manufacturer and the capabilities and features food manufacturers need from a CMMS. Ibnu, thank you so much for being on the podcast today. How are you?
Good. Thank you very much for inviting me.
So I'm really looking forward to our chat today. So your career in fast-moving consumer goods manufacturing started in Saudi Arabia. And for the last 7 years, you've been at Gosh Food here in the UK. How would you describe what running maintenance at an FMCG manufacturer like Gosh actually involves on a day-to-day?
Yeah, so just to give you a quick background about myself. So I did my bachelor's in mechanical engineering back in India. I'm originally from India. And then right after I finished my studies, I went to Saudi Arabia and joined a food manufacturing company there as a maintenance engineer. And after 2 to 3 years working there, I was promoted to a reliability engineer. And then for a few more years, I moved to UK where I joined Gosh as the maintenance engineer again. So it's been a quite good experience so far for me when it comes to the maintenance management and everything. I've learned quite a lot. So coming from a company in Saudi Arabia where we had about 52 employees just in engineering full time, not counting the contracts agent staffs, to a company that's only have one shift engineer per shift. It was quite challenging to start with, and any small downtimes affect the overall throughput or overall output of the company, because it's basically what we are there for. We are a support function supporting the production. So so it's been quite challenging, but it's part of the job. So
And what would you say is the biggest challenge going from like a team of 52 to having that one shift engineer?
So having a bigger team, you've got better resources, not better, you've got a bigger pool of resources when it comes to manpower and in terms of skills availability. So you've got more versatile skills force within your team that you could, depend on when you've got problems in terms of downtime or breakdowns, or even on if you've got any improvement projects that you can rely on a lot of people. But when you are down to just one engineer per shift, the skills are limited. It's not disrespectful to anyone who's working as a lone engineer, but it is the way it is. It is either we have to train them up, but obviously it depends on what skills that the business is expecting to get from that engineer. So that's the only skills that they're gonna be having. So that was one of the things. And plus, if you are one shift engineer, if you're one maintenance engineer managing more than one lines or multiple lines, imagine you've got 2 breakdowns on 2 different lines and you're only one to manage them both. That is quite challenging and could be stressful as well.
If you have a scenario like that, how do you prioritize?
So it's basically communication with with the production department, basically, to prioritize which one they need us to attend first. So we usually go to the shift manager or the production manager and then speak to and say, okay, look, we've got 2 lines that's down. So which one would you want me to attend first? Or probably when we hear about these issues, we would know, probably we could think sometimes from our experience, we would know, okay, this line issue could be fixed in 5 minutes. The other one could take about 30 minutes. So in that sense, in that scenario, we would go to the shift manager and would say, okay, look, this is a quick win. So maybe let me focus on this first, get it running in 5 minutes, and then can go attend the second one. But if both of them are quite major breakdowns, then obviously we'll have to escalate it and find out the priorities from the other department or from our manager, kind of thing.
Yeah, and obviously when you're working with perishable products, tight delivery windows, there must be a lot of pressure when it comes to scenarios like that.
Yeah, so especially I mean, I've been only in the food industry since I've started my career.
Mm.
And one thing that is challenging about the food industry is that the life of the product. So you've got an expiry. So it's
Mm.
not like your stock went down in your warehouse and then we just produce the stock. We can't do that. So we only have to do it based on the expiry of the product, and it's a really tight window when it comes to that. So if you
Yeah.
lose one production on a Monday, and then it'll be really hard for the planning department to work around it. So that stress comes down to the engineering when it comes to your breakdown, that we have to cope with it.
Mm. Now, do you have planned shutdowns for maintenance?
So in the past, when I started, we didn't. We were 24/7 back then. So we've had a
But this is
few.
at Gosh, yeah?
Gosh, yeah.
Yeah.
So we were 24/7. So we had a bit of a leeway. We have a bit of a gaps between the production within the lines that we could utilize, but there was nothing as such as a planned shutdown kind of thing, what it was dedicated for engineering to work on. But in the last a couple of years, I would say we've had this process put in place where we've got a planning meeting every Friday, and where engineering is now involved. So it's not just engineering in the planning meeting. So we've got the operations, production department, some from QA, some from hygiene, to put in their cleaning schedule into it. So we all sit together on a Friday afternoon. And we usually, from our side, as a supervisor, I used to send the upcoming week's scheduled work prior to this meeting to the planning department, and they would try and integrate it within the production plan so that they can allocate us some slot to work
Okay.
on. Yeah, so that's one way we have managed to improvise it. So that's quite helpful, I would say. I mean,
Yeah.
there would still be some cases where obviously if you're only running with one shift engineer and you've got a maintenance window, let's say from 10 to 11, and maybe that shift engineer would be busy with some other issues on another line, and then we lose that window, and then we kind of reschedule it probably the next day, or maybe it would roll on to the next week, depending on how critical the maintenance was.
Yeah, that's really interesting. Have you noticed a difference in reduction of unplanned downtime or anything else since starting these Friday meetings and planning for this shutdown?
Yeah. The one thing that we did notice is we get a bit more relaxed time, or we kind of get this feeling that we're in more control when it comes to the maintenance. Because back in the days, we were with mostly firefighting. So the machine breaks, we go fix it. Another one breaks, we go fix it. We don't get the chance to schedule everything into the planning. But now we are getting it, and also with the implementation of the CMMS kind of thing, we are getting a bit of an historical data where we could look into the past and see, okay, we've got some issues every 3 months on this particular machine, and then we could put that into a scheduled maintenance work. So it's been better, I would say.
It's really interesting. I'd love to come back to that a bit later. I just want to get a sense of, your sort of day to day. So roughly how many work orders do you manage there weekly?
So weekly, we are roughly about, I'd say 50, 55 to 90 work orders a week.
Yeah.
I mean, we are not 24/7 anymore. We're only Monday to Friday, but we're still 24 hours. But yeah.
And that's manageable for your team of 5, I think it was? Or does it feel a bit pressurized?
Yeah. The one good thing that we've got now is that we've got multiple engineers on night shift, which is quite helpful, because one of them, I could assign one of the engineers to cover the shift in terms of breakdown or reactive, and the other guy on the plan kind of work. So it works out good that way. So yeah, it's not that bad. I would say it's 50 to 75 would be okay.
Yeah. And what sort of balance is there between, your planned, reactive, and improvement works in your work orders? Would you say it's more planned, it's more reactive?
So, well, at the moment it's more planned. So we are
Mm.
working towards reducing the percentage of reactive works when compared to the planned works. We were trying to get it down to below 20% or about
Okay.
15%.
Yeah.
We used to be roughly about 35% when we started tracking everything. But now we have brought it down to an average, below 20%. And we are kind of about to, we are reaching the point where we would be thinking hitting a 15% reactives compared to a planned maintenance.
Yeah, excellent. And is that a KPI for you, for your
It
team?
is. It is one
Yeah.
of the KPIs that's been given to us since 2025, beginning of the
Okay.
year.
Yeah.
Yes, we have been trying to track it. We've been trying to challenge it, and we are getting better at it.
Yeah. And I guess a big part of that is having that CMMS system you've mentioned there.
It is. It is. It helps us to obviously track the number of reactive jobs that we do, and it also helps us to. I think pretty much every CMMS does the same. I think that's
Hmm.
the helpful part of it. It shows us which machines that we're working on quite a lot, which machines are we working on the reactive side or more, and which machines that we need to focus on, which one's more reliable, which one's less reliable, and all that sorts.
And I guess that's quite important for you because I know you've got a mix of older and newer production lines. So how does having that spread of equipment ages change the way you approach your planned maintenance?
So regarding the planned maintenance, when we structure the works for the maintenance or the
Mm.
preventive maintenance for different kind of equipment based on the age. So what I follow is if it's a new line of equipment, which is probably about, if it's less than 5 years, this is kind of my thumb rule. If it's less than 5 years, what I would do is I usually stick to the operations manual or the maintenance manual that's applied to us by the manufacturer.
Hmm.
So we usually adopt, pretty much copy all the activities that we get from the manufacturer's manual, put it
Okay.
into our CMMS, and then follow that. Now, if a machine or if a line of equipment is way older than that, then obviously we're gonna have to look back into the CMMS work orders that we have created for this equipment, and then we take some insights from it. So basically, we look into historical data from our experience from the engineers, and then we would think, okay, maybe that sort of belt or that bearing is failing every
Mm.
2 months from the data from the CMMS, and then we take that and then we add that into the maintenance schedule and saying every 2 months, regardless if it's in a good condition or not, we're just going to replace the bearing, or we're just going to replace the belt, so that it's kind of preventive, so it doesn't cause us unplanned downtime.
Yeah.
Yes, that's what how I would structure the plan works for a new and old machines.
So that mix of manufacturer, uh, data and historical data, that mix is helping you plan your
Yeah,
maintenance there.
yeah.
Do you have some sort of notification and alert system set up? Do you have a weekly, on your Friday meetings to understand, okay, this is coming up, this is happening next month?
Yeah, so we on our email system, we have got an option to set up all the maintenance activities on a schedule. So,
Mm.
and it auto generates. So if it's a monthly work, it auto generates every month. Either we can set it up on a particular date, or we can say, after the completion date, or a month after a completion date, it starts up again. So it comes up every month, and then I can look into the schedule or into the CMMS and look into it and find out, okay, this one's coming up next week, so I need to put this into the planning schedule.
So is there, you've mentioned you use eMaint CMMS system. Do you use anything else like spreadsheets or anything? What does your tech stack look there?
Um, Currently we don't use any spreadsheet, other than we do use one for a quarterly, like a charter, maintenance
Hmm.
charter for major works. and it's on a shared drive in Microsoft Office, and it's collectively, or it's being shared with my engineering team, our engineering team, my engineering manager,
Mm.
and also the head of operations. So so everyone's aware of what's happening in the next 1 quarter, kind of thing. So that's the only thing that we use on a
Okay. So
spreadsheet.
the priority of maintenance tasks is all based in your CMMS.
Yeah, yeah.
Yeah, excellent. And for any listener or company weighing up a system for like a small or mid-sized FMCG manufacturer, what does that system do well for you? Like what capabilities and features are integral to how you run your maintenance strategy?
So the main thing, so we have been introduced to something called the maintenance pyramid. So I'm not sure. It was quite new to me. I only heard about it last year,
Hmm.
but this actually it's a really helpful tool, or it's a really helpful chart where it shows has got various hierarchies of items that we need to hit in order to get into a world-class maintenance department. And so we usually try to hit green on pretty much
Mm.
all the levels in there. So on the basics, or on the base of that pyramid, is mostly work order management, or work order history, data reporting, asset register kind of thing.
Mm.
So that's basically what we would need to start with on a CMMS, I would say, where you either yourself as an engineer or anyone from production to raise a work order, and then you being able to put your data in it, and on a preventive maintenance side, you should be able to structure a PM
Mm.
schedule into it. That would be minimal for any company to start with, I would say. And spare parts, MTTRs, MTBFs, and everything else, it's always the second step, I would say.
Yeah. And is there any way you feel limited by the system, like something you wish it could do that help you improve the way you run maintenance tasks?
Yeah, so at the moment, we are looking at, we're exploring the options of getting this software into mobile phones. So our engineers, they use phone.
Hmm.
Every has got a shift engineer phone. And at the moment, what they are struggling with is obviously they will be busy in the factory floor doing the work.
Mm.
And obviously, we need the data visibility once they have done the work. Now they're having to come back into the office, into a computer, to do all their shift reports. Now, if it's a really bad day or a bad week, most of the times they're gonna have to wait till the end of the shift to go back into the computer, because they don't get a chance to go back to the
Mm.
office. But introducing a mobile version of the software would help them to sort of raise it there and then when they're on a work, and close it off right after they've done the work, so that they don't miss any
Yeah.
data, they don't forget anything. So that's something we are looking into. And another thing is the MTTR and MTBFs. These are really valuable, or really important critical factors that you could use as either as a maintenance engineer or maintenance manager, whichever level you are.
Mm.
They're really helpful. And the current software is not, I would say, it's not that precise when it comes to MTTR, MTBF. And I believe it's purely because I think the production plan should be tied into a CMMS. And I know I don't think it's conventional that way, because most of the CMMS are purely focusing on internal work of a maintenance
Yeah.
department. But the thing about MTTR or MTBF is that the values are calculated based on the number of hours the equipment was in production. Now, most of the times, the CMMs wouldn't know unless we put it in,
Yeah.
or they would go with the default value of, okay, the machine was running 24 hours, and then they take the downtime hours into consideration and work out it that way. Now that doesn't give you a realistic data, so that is one thing that we are struggling with at the moment.
Yeah.
So what I do at the moment is that I download all the, so for example, a year's data every end of year, I download all the data into a CSV or an Excel file and then work it out that way. It's a bit manual process.
Yeah, still very manual, I guess.
Yeah. But that is one thing we haven't got in there.
Is there a case then for possibly introducing something like condition monitoring tools in there? Your analysis, your sort of sensors, to understand that runtime?
We could. I mean, at the moment, we have got a separate system that we use for real-time monitoring of production. It is a different. It's another supplier of software where we've got sensors and bits on the line, and
Okay.
it calculates how many products have been produced, and what time the line started, and what time the line stopped, and what was the planned downtime, what was the unplanned, what was the setup time. It's quite good, but obviously it's in a different system compared to a CMMS.
Mm.
So, but yeah, we do have a system that. So I'm having to take the data from a few sources and then compile it to one.
Yeah.
So maybe in the future they might be able to integrate it, but who knows?
Yeah. One of the improvement projects you run at Gosh, one that really stands out is the new date coding system. Could you just talk us through that? Like, what was the initial problem and what did it fix eventually?
Yeah. As a food manufacturing company, as I said, the critical factor is the expiry of the product, and the
Mm.
date coding is really critical when it comes to printing the date, the use by date on the product. Now, if it's a factory like us, we are running quite a lot of variants of products, and the life of every product could be a bit different. It could be 1 or 2 days, or maybe 5 days, but it's still different. Now, the existing date coding or the date printers that we had on our lines were pretty much the operators would have had to go into the printer and then pick the product manually, and then go and pick the use by date manually.
Mm.
In the sense, you've got offset programs, but that is how they used to do it. Now, when it comes to the skill levels of the operators within the factory floor, you don't get a uniform skill level across everyone or across every shift. We've got 3 shifts. Now, if someone is absent during the day and another one has to step up, they would try to pick this program up manually, and may, you know, lack of skills may mess it up and
Mm.
they pick the wrong program in. And then obviously they may have run a half a batch of product through with the wrong date printed, and then they pick it up later, and that's a
Mm.
lot of rework going back. Now, obviously, we've tried providing training to these operators, but obviously, as I said, we can't get uniform skill levels across the whole factory. So that's when we thought, okay, we could try thinking of something else. So we had this a new supplier who came to us with a new inkjet printer, where we could set up the programs in corresponding to the barcode on the product. So basically, we scan the barcode on the product, and then it loads the program by itself. So there's no manual involvement or anything. So when they're about to run the product, they pick a product from the line, they scan the barcode before they start the production. Obviously, they
Mm.
scan the barcode, and it comes up with the use by date, the picture of the product, so that they can confirm it and everything. So it was kind of like a poke process in continuous improvement. It's kind of mistake, error proofing. So that was one thing that we improved on that project. Another thing was the consumables when it comes to an inkjet printer. So
Mhm.
you are required to use quite a lot of inks and makeups, solvents, and cleaning solutions. So we had 3 different consumables to run this date printer, and we didn't know that we were using quite a lot until we found this new supplier who, with their data, they came to us and proved us that their solvents or their consumable was 60% less
Okay.
compared to the other one, compared to the existing one. Plus, they wouldn't need any cleaning solution because
Mm.
their solvent would do the cleaning itself, and operators or the engineers wouldn't have to go into it to create a cleaning schedule or stop the machine and do it. we didn't have to do that.
Yeah.
Anytime there was no production, we put it on a smart shutdown. The printer cleans itself. So, and uses lesser solvent to do the cleaning as well. So we save quite a lot of, chunk of money on that consumable side on there.
Yeah. And
And
you've also reduced that shutdown period as well.
exactly, yeah. So
Yeah.
it was quite a good improvement. So yeah,
Yeah.
really
And I
proud.
guess that really brings to the front, that desire for continuous improvement, figuring out, little things. How can we improve this? How can we do this? And it all ends up being, efficiency and better productivity on the production line as well.
Yeah, yeah.
So you've written publicly about using fishbone analysis for root cause work. I found it really interesting. How does that structured problem solving feed back into your maintenance schedule?
So, fishbone diagrams was something that I learned in my previous company when I was in a reliability engineering role, and it's really useful when you are really struggling. I mean, every engineer who has worked on a particular line or particular equipment for a few years, in time they would kind of figure out, when they get the symptom of issues or anything, they would be able to find the root cause pretty easy. But there are going to be some issues where you're kind of scratching your head every time.
Mm.
Let's say every year you're getting it 5 times every year, and you think you would have fixed it, but it still comes up again. So these kind of issues, plus if it causes a big majority of your downtime, it's a bigger headache. So that's when you really want to drill deeper and then find the root cause so that you can get it fixed once and for all. So that is one of the cases where you could use a fishbone diagram. It looks into different multitudes of causes or factors that could in any way vary a process or an equipment or whatever it is that you're trying to solve. So usually from an engineering side, we usually go with a few fixed variables. This is so basically you've got a breakdown. You say it could be because of the machine itself. So one part, lack of maintenance, whatever it is. Number two would be, materials that they're using on it. So they might be using a wrong lubricant, or they might be using wrong raw materials, wrong film, wrong type of film in it. Or it could be the people, so it could be manpower, lack of skills, or wrong operator on the wrong line, or, so it goes into various multitudes of issues or factors that you could drill deeper and then go in. So it's quite useful if you're using. I mean, you don't really necessarily need to use it for every breakdown that you've got. But if you want to drill deeper into a particular issue to find the root cause, it's really bugging you, then yeah, it's really quite useful.
And you've been able to apply that at Gosh Food as well.
Yeah, I mean, we have had a few issues on our refrigeration side. So we have worked on that one. We have had issues with our ovens, where we are having some issues with the motors being failing every quite frequently. So basically, we look into one thing to look for is the CMMS to find out how frequent one issue is happening or how frequent the same issue is happening, and then look into it and say, okay, so maybe every quarter you can sit down and then review it with. You can either review it with your engineers or with your manager. It's up to your availability, but you can go through the issue, get a whiteboard, draw a fishbone, and then find out what could cause the issue, brainstorm it, and then you find out, okay, maybe you will find out more than one issue, and then you gotta work out your way through it. But you find it out, then you put it into your scheduled maintenance and say, okay, we're gonna do this, we're gonna try and do this and see how it goes. So if that issue has been happening every 2 months, you've done this corrective solution into it, and then that 2 months became 5 months, for example, then okay, so that had some effect on it. So you can try and go from there.
Yeah, and I guess that brings back the importance of communication and internal knowledge as well.
Yeah,
It's like nice and rounded.
Yeah, that is correct. Yeah, the feedback from the engineers are really valuable
Yeah.
into this fishbowl. You could also another person that you could involve in it is if there is an operator that's been working on that machine for quite long, you could actually involve the data from him as well. It's just quite useful.
Yeah, there's nothing more valuable than someone's hands-on who's doing it
Exactly.
24/7, So yeah,
Yeah.
awesome.
Yeah.
Ibnu, if a listener takes one thing away from this conversation about what good maintenance looks like, and what do you want it to be?
One thing that the challenging thing about FMCG when it comes from as an engineering side is that you are a support function. You are never the primary function of an FMCG environment. So you're always there to support production. Production is the primary, and in a fast-paced environment, downtime, even if it's lesser, whatever it is, it will create a bigger problem. It will create a knock-on effect. So most of the times, engineers would try and fix the symptoms just to get the line going,
Hmm.
and and most often they're not able to go back to the problem to find the root cause and fix it, and then it would escalate into more problems. So this is where the firefighting, most of the companies that I've seen or I've spoken to has got this firefighting going on, and once you get into that, it's really hard to come back into this corrective or planned maintenance work. So you everyone will have to find a way where you've got you plan to find some time to sit down, go through your historic data and find out what's the main issues, and then try and find some time to find the root cause and get the issue sorted. In the long run, it helps a lot.
Yeah.
So, yeah. So that's
Well,
what I would say.
that's awesome. Ibnu, you've been a brilliant guest. You've given us such a practical view of what it takes to run maintenance well in manufacturing. And that's going to be useful for any maintenance manager or engineer, wrestling with that unplanned downtime, tight production windows. And when it comes to selecting a CMMS as well, some good capabilities to look out for there. So thank you so much for joining us, Ibnu.
No problem. Thank you very much for inviting me again. Thank you.
Awesome. And thank you all for listening, and we'll see you on the next episode.
Thank you.